This is a motor driver circuit L293D. This is a motor driver IC where it drives some motor with the help of Arduino signal. And I will just show you how it works. To make the video short, I have skipped the loading part, and now I'll just show you how it works. Actually, this is an L293D motor driver IC where sorry where we are controlling this motor driver IC with this potentiometer. So not potentiometer, photoresistor. Actually, it is an analog sensor. We are taking the values from the analog with this pull-up resistor. Uh, Between the pull-up resistor, we are taking the values of the analog this sensor. By this value, Arduino will give the commands to the L293D module. I will just let you know how it is working. This is an enable pin for the working of two oh, two sorry two outputs of this L293D IC, where this is the input signal from the Arduino that we need to give uh, the signal. By manipulating these inputs, this is the input one, and this is the input two. By manipulating these inputs, we can control the output pins of any other voltages. This is the secondary voltage source power 2, where uh, it directly connects, drives this power to the motor. And this is the power pin 1, where this power need for the L293D IC to operate all these functions which need to be powered. And these are the ground pins of these ICs, and this is the output pin, output 1, which is directly connected to the motor or one terminal, and this is the output 2 terminal which is connected to another terminal of the motor. Here, one thing is, uh, we don't have any polarities of this motor. If we are giving this as positive and this pin as this terminal as negative, if it is rotating as clockwise direction, if we just change the polarities of these wires, then the rotation will be an anti-clockwise. If first a previous one is clockwise direction. These all are about the rotations and controlling of the LED, sorry, of the motor. If input signal is if input 1 is high and input 2 is low, then the motor will rotate in clockwise direction. And if it is in reverse order, if input is low, 1 is low and input 2 is high, then it will rotate in anti-clockwise direction. Mm. And this is another main point is uh, the negative the negative of the external source and the uh, main power source will be need to be connected mutually, otherwise the circuit will not complete and uh, it will not work. I will just show you the basics, first simulation of that, how it is working. First of all, I have used this photo sensor. It detects the light. So initially it is rotating in a clockwise direction because it is showing in 16530 RPM, and when it is in dark conditions, and when it flash a light on this photoresistor, uh, then it will rotate in anticlockwise direction with this minus symbol. This is how we are controlling this motor directions using driving this motor using L293D using this photo sensor. Mm. Now I will show you how the coding part where how it is working. It's as simple as that. Where uh, where I have chosen the input pins as input 1 and input 2 as 11 and 7th. By these two digital pins, I have controlling this L29 3D module, and another one is an this A5 sensor, which is connected to this photoresistor sensor. Uh, and this serial begin will show you the values of this photoresistor, what are the values it is getting. So in the looping part, I have stored the array sensor values in a variable way in a variable val. It is an integer type, and after that, I have written an if conditions where variable val will if the stored variable val is greater than 800, means the value which is stored in the variable which is if greater than 800, then it will give the digital write as input 1 as high and input 2 as low, and with the delay of 1 second. And I have written another conditions where if variable value is less than 800, if it is less, the potentiometer value is less than 800 then it will give the reverse order. Uh, Seventh pin will get high and 11th will get low. That means input 2 will get high and input 1 will get low. That's that's the only thing happening here. Thank you.